Welcome to the Deep Dive, where we unpack the stories behind the headlines to get you truly well-informed. Lately, it's been pretty hard to ignore the news about Elon Musk's surging net worth,
Right.
hitting an astounding $385 billion. I mean, that's more than twice Bill Gates' $176 billion.
It's incredible.
And a significant part of this seems linked directly to the buzz and now the recent debut of Tesla's robotaxi service. So the big question on our minds, and hopefully yours too, is how is one person actually accumulating this level of wealth? And maybe more importantly, what does it really mean for the future of transportation and, our cities?
That's really the heart of what we want to explore today. We're going to dive deep into, well, the whole multifaceted world of Elon Musk's business strategies.
Okay.
Everything from his unique operational philosophies to this really ambitious rollout of Tesla's robotaxis. We'll look at some real-world user experiences with full self-driving, or FSD.
Right, the actual driving part.
Yeah, exactly. And then we'll kind of zoom out, look at the broader societal legal implications of autonomous vehicles, AVs, in our urban landscapes. Our goal here is to pull out the most important nuggets of knowledge from a bunch of different sources, just to give you a clear, really informed picture of this whole evolving landscape.
That initial surge in wealth, it just really sparks the question. How do you even build an empire capable of that kind of rapid growth? And I guess to answer that, we need to understand Musk's overarching business philosophy, which seems to go way beyond just the products themselves.
Definitely.
And into some truly unique, like you said, sometimes controversial workforce strategies. It feels like it's not just one company, it's this entire ecosystem of disruption.
Precisely. And his core strategies are quite distinct. They're really crucial to understanding the success. First off, there's just this overwhelming dominance of engineering and operations roles. Right across his ventures. At SpaceX, for instance, you're looking at like 48% engineering, 31% operations. At Tesla, it's a bit different, maybe 26% engineering, but 43% operations.
So heavy on the making and doing.
Exactly. This structure isn't just about building things. It's like the absolute backbone of their relentless push for breakthroughs and operational efficiency.
Okay, so it's not just what they build, but who builds it and how they're organized. That intense focus on engineering and ops, it really sets the stage. But I imagine there's more to this unique approach than just those numbers.
Oh, absolutely.
Yeah.
Secondly, we've seen some pretty radical restructuring. I mean, the most famous example is probably the controversial decision to cut nearly 80% of Twitter's staff after the acquisition.
Yeah, that made headlines.
Right, it set a new, maybe extreme bar for what he calls lean operations. Thirdly, there's this huge emphasis on cross-disciplinary genius. Think about Neuralink, for example.
Okay.
It's integrating neuroscience, AI, and robotics to achieve breakthroughs that, would probably be impossible within just one single field.
Right, combining fields.
Or look at Tesla buying SolarCity. That transformed Tesla into a comprehensive clean energy provider by basically blending automotive tech with solar and battery stuff.
The key insight, I think, is that Musk isn't just building companies in isolation. He's engineering this integrated ecosystem where all these diverse disciplines converge, aiming for, exponential innovation.
That's a really powerful way to frame it. Engineering an ecosystem, not just a company.
Yeah.
Okay, and what about the talent side? How does he get the people?
Well, his talent acquisition strategy seems very industry-focused. For SpaceX, the top hires often come from established aerospace giants, NASA, Boeing.
Makes sense.
Whereas Tesla tends to recruit heavily from tech leaders like Amazon, Apple, Google. But what's also fascinating is the amount of cross-pollination of talent within his own ventures.
Ah, like moving between companies.
Yeah, exactly. We've seen reports of Tesla employees, for example, doing code reviews for X, formerly Twitter, which means you get shared knowledge and skill transfer happening across these seemingly different companies, which just reinforces that whole ecosystem approach we were talking about.
It really does sound like a sprawling, interconnected web of innovation. And speaking of expansion, we've seen some pretty significant updates just this year, 2025, that really underscored this continued growth. Each one feels like a compelling example of that cross-disciplinary thing and that relentless pursuit of scale you mentioned.
Right.
SpaceX, for instance, just got FAA approval to ramp up Starship launches from 5 to 25 annually, and Starbase actually incorporated as its own city.
Wow, its own city.
Yeah, talk about operational dominance. Then Neuralink is launching its first human clinical trials outside the U.S., up in Canada, pushing those boundaries of neuroscience and AI.
And the list keeps going, doesn't it?
Yep.
xAI, his AI company, just unveiled Grok 3, now with vision capabilities.
Yeah.
And it secured massive funding, $12 billion at, what, a $35–40 billion valuation?
Huge numbers.
Yeah. And Tesla's making this significant shift towards humanoid robotics with the Model V, plus their plans for the Redwood mass-market EVs. That really speaks to that core engineering focus.
Right.
Meanwhile, Starlink, the satellite internet venture, is increasingly becoming like a U.S. foreign policy asset. The government's even encouraging its international adoption in trade talks. So yeah, it's clear the scale and ambition are just constantly growing, constantly pushing the envelope.
Okay, let's shift gears a bit to the immediate excitement. That June 22nd debut of Tesla's robotaxi service down in Austin, Texas.
The big one.
Yeah. The initial pilot program, it sounds quite specific, a select group, investors, enthusiasts, using Model Y robotaxis, but only in a geofenced area.
Right, geofenced, meaning it's restricted to a very specific pre-mapped zone, like a particular neighborhood or district. Can't go just anywhere yet.
Got it. And operating hours are 6 a.m. to midnight, accessed via a dedicated robotaxi app with what, an initial fleet of maybe 10 to 20 cars?
That's the initial plan, yeah.
Yeah.
Very small scale to start.
And Musk even promised the first totally driverless trip from the factory to a customer by June 28th. So this feels like a major step, but what does it all mean for that dream of truly driverless cars? Is this it?
Well, it definitely signals Tesla's unique business model for robotaxis. And it really sets them apart from competitors like Waymo.
How so?
Because Waymo basically covers all its own operating costs, right? They own and operate the fleet. Tesla's plan is different. They want to sell robotaxi-capable cars, including these purpose-built cybercabs and cybervans they're talking about, for under $30,000.
Okay.
And sell the full self-driving software. Then they plan to profit share from the actual rides with the car owners.
So the owners handle the day-to-day.
Exactly. The owners would cover charging, cleaning, maintenance, insurance, effectively turning their cars into, well, what some people are calling a money-printing machine.
Catchy phrase.
It is. But it raises that important question. Why would Tesla, a car manufacturer, decentralize its robotaxi fleet like this? The main argument is that this model lets Tesla avoid incurring these massive capital costs and, frankly, the huge logistical challenges of operating a global fleet themselves.
Right, they shift that burden.
They shift that burden and potentially the profit opportunity directly onto the individual vehicle owners.
That money-printing machine idea, it certainly sounds appealing to an owner, but it also feels like a huge decentralization of responsibility. Does this fundamentally shift the financial risk away from Tesla? And what are the potential downsides, like for quality control or consistency of service, if the fleet isn't centrally managed by Tesla?
That's a really crucial point, yeah.
It seems like such a radical departure from how other AV companies are approaching it.
It absolutely is, and it's something investors and future users definitely need to consider. But maybe let's move from the business model to the actual experience.
Yeah.
What's it actually like using this technology in the real world? We have some direct user feedback from a pretty intensive 3-month review of Tesla's full self-driving, the FSD.
Right.
This was on a 2024 Model Y with Hardware 4, covering about 5,500 miles using FSD. Hardware 4 is Tesla's latest computing platform designed for better processing, better sensor capabilities for autonomous driving.
So the newest setup. Let's get into the nitty-gritty then. What was it actually like?
Okay, let's break it down. Maybe the good, the bad, and the ugly.
Sounds good. What impressed the user? The good.
So on the positive side, the user reported that FSD, especially when set to chill mode, delivered what they called chauffeur-like driving, about 99.9% of the time.
99.9%.
Yeah, smoothly handling most situations. And it apparently significantly reduced driver fatigue on long drives and in heavy traffic, made the commute much less stressful, they said. So for that consistent, predictable highway driving, it really seems to shine.
That sounds incredibly impressive for the majority of the time. But even at 99.9%, there's still that little fraction of a percent left over. So what were the frustrations?
The bad.
Okay, the bad. This included things like occasional lane drift, especially when making left turns, which, could create potentially dangerous situations.
Yeah, you don't want that.
No. There was also apparently a really rigid route selection. FSD always defaulted to the highway, even if a human driver would know a local route was better, maybe to avoid certain things like poorly covered haul trucks was one example given.
Right, local knowledge it doesn't have.
Exactly. And it was difficult to define alternative routes. The system didn't seem to learn user preferences over time, and it didn't consistently offer alternative routes either. It often felt like it just had its own stubborn mind about where to go.
Okay, frustrating. And then the ugly. This is where we get into the real surprises, right? The moments that really test your trust in the system.
Indeed. The ugly refers to these rare but described as alarming and very, very unpredictable incidents.
Yeah. One user reported FSD actually accelerating towards a highway on-ramp that was blocked by a chain link fence. Required last-second human intervention.
Good grief. That would absolutely make your heart stop.
You'd think so. Other reported issues, maybe not quite as dramatic, but still concerning. Phantom braking, the car braking suddenly for no clear reason.
Heard about that one.
Sudden steering off the road sometimes. Struggles in construction zones. Ignoring school zone speed limits. Making what the user called bad fork choices in the road. Hard braking, then kind of gliding slowly up to stopped cars. And apparently poor right turns from stop signs. It's just really important to remember FSD is still considered a level 2 system, right?
Right. Driver assistance, not full autonomy.
Exactly. It provides advanced driver assistance features, but the human driver remains fully responsible. You have to constantly monitor the road, be ready to take over at any moment.
So it's very much still a co-pilot, not a fully autonomous driver you can just tune out. Okay. Given those experiences, what were users suggesting for improvements? What would make FSD feel more intuitive or reliable?
Well, users suggested more granular, user-defined adjustments for things like speed and acceleration preferences.
More control.
Yeah, more control. There was also a strong desire to be able to persistently correct wrong turns, or those repetitive phantom braking instances. Like, let the user influence the system's behavior over time, almost teach it.
Like training it.
Kind of. And many also wanted something like a ChatGPT-like voice assistant. They could actually remember preferences and commands given just in plain English.
Interesting. Makes sense.
And regarding the cost, that $99 a month subscription, while some found it worth it, especially for long drives, many users suggested a lower price point, maybe in the $29 to $50 range, just given the active supervision that's still very much required.
Yeah, that feedback makes sense. It's clear there's still a significant gap between the aspiration of full self-driving and the current reality for many users. Okay, let's broaden our scope now. Let's talk about robotaxis in the wider urban context.
Right. The bigger picture.
Because on the surface, they promise these incredible benefits, right?
Yeah.
Increased safety, maybe greater accessibility, environmental advantages. It sounds like a dream for urban mobility.
Yeah.
But what are the roadblocks, especially when this cutting-edge tech meets the, let's face it, messy reality of public roads?
Well, the roadblocks are significant, particularly when you look at the complex legal and regulatory landscape.
Okay.
One major issue is just the sheer lack of consistent national regulations. Companies are basically forced to navigate this patchwork of widely varied state and local laws.
Amazed.
Totally. For instance, California has really strict permits, data reporting requirements, which makes it harder to deploy robotaxis there. Whereas Texas has actively positioned itself as AV-friendly, even preventing local governments from restricting AV operations. This inconsistency creates a really confusing and often potentially litigious environment for actually deploying these things.
And what about that crucial and frankly kind of unsettling question of liability? When a driverless car crashes, who is actually at fault? It's not like there's a human driver to point the finger at.
That's a deeply complex and honestly still pretty unresolved question. For traditional cars, liability usually falls on the human driver.
Usually, yeah.
But with AVs, is it the vehicle owner?
Yeah, the manufacturer.
The software developer.
Yeah.
Texas law, for example, actually states the owner is responsible for the AV's compliance with traffic laws.
Interesting.
But Tesla, on the other hand, consistently denies liability for crashes involving its FSD systems. They argue that drivers are ultimately responsible even while they're marketing FSD as this advanced, almost autonomous system.
That feels like a contradiction.
It certainly could lead to significant legal battles down the road, especially when you consider the NHTSA, the National Highway Traffic Safety Administration, is actively investigating Tesla FSD-related crashes. There were 299 reported just in Texas since 2021.
Wow, 299. Okay, so beyond the legal hurdles, there are these significant societal concerns, too. We've seen protests, right? Groups like Safe Street Rebel claiming robotaxis are effectively above the law, that they can't be cited for traffic violations, and they refuse to share incident data. That really highlights the tension when new tech tries to integrate into existing public infrastructure and community expectations.
It certainly does. And critics argue that robotaxis, much like ride-hailing services we already have, like Uber and Lyft, might actually draw riders away from public transit.
Making traffic worse.
Potentially, yeah. Ultimately increasing congestion through deadheading, That's when empty cars are just circulating without passengers looking for fares. Now, Waymo has tried to collaborate with some transit agencies, offering credits and things, but logistical challenges remain, like the simple lack of dedicated curb space at transit hubs for pickups and drop-offs. That raises both safety and congestion concerns right there.
So, despite the futuristic vision, there are these very real-world impacts on how cities function, how people get around, and cost has got to be a factor here too, right? Because public transit serves a different, maybe more fundamental need for many people.
Absolutely. Robotaxis, at least for now, remain significantly more expensive compared to public transit. That limits their appeal, especially for low-income riders who really rely on affordable bus or train services. And fundamentally, public transit is just far more efficient for moving large numbers of people sustainably and reducing emissions per passenger. That's a key consideration for any kind of urban planning.
And then you layer on the ethical dilemmas, which always seem to emerge when technology pushes boundaries like this. The potential for job displacement, I mean, for millions of drivers, not just Uber and Lyft folks, but potentially truck drivers too. If AVs expand into freight, that's a massive societal issue we haven't really grappled with yet.
No, we haven't.
And we still haven't resolved that truly complex question of how AVs should make ethical decisions in those unavoidable crash scenarios. You know, the trolley problem, but with cars.
Ugh.
Prioritizing passengers versus pedestrians.
Right. The algorithms making life or death choices.
Exactly. These are profound questions that touch the very fabric of our society, and they're going to require some really thoughtful solutions as this technology keeps advancing.
For sure.
So we've taken quite a deep dive into these sources today, and I think it's clear that the road ahead for autonomous vehicles is, well, anything but straightforward.
Definitely not smooth pavement yet.
No.
Right.
We've seen this incredible technological advancement, the immense wealth generation driven by someone like Elon Musk's vision, but that's sharply juxtaposed with these significant real-world challenges, public adoption hurdles, regulatory mazes, and all these unforeseen societal impacts for robotaxis.
That paradox is absolutely key. While robotaxis represent this, potentially transformative technological leap, their actual integration into our urban landscapes is going to be pivotal. Cities like San Francisco, LA, Phoenix, Austin, they're serving as the real-world testing grounds right now.
Learning as they go.
Exactly. And the lessons learned there will be crucial for everyone else, which I think raises an important question for you, the listener, to consider. As this technology continues to evolve, what balance will we need to strike between fostering innovation and protecting the enduring needs of public safety, maintaining urban infrastructure, and supporting sustainable public transit?
And maybe digging a bit deeper, how much human interaction or oversight will always be necessary for systems we call full self-driving? Is truly full self-driving, with zero human input ever needed, actually achievable or even desirable in our complex world?